Okay, next section. It says the groupies manager was doing a great job, so they decided they were going to help her out on their next trip. They were going to make a graph of the cost of the trip depending on the amount of people going. The tickets are still $40 and it's only in Aberdeen, so gas will cost $60. We're supposed to create a graph of the trip that compares the amount of people going on the trip and the cost of the trip. Okay, so far we've realized that to graph, the best way to do that is to create a table and then plot those points. So we are dealing with ticket or people going, and we are comparing that to the cost of trip. Okay, so we could write an equation here. We have got $40 per person plus the $60 of gas is going to equal our cost. So if 0 people go, technically nobody can go. If that car drove itself, as weird as it is, it would be $60. If 1 person went, it would be $100. If 2 people went, hopefully you're starting to realize there's a pattern. For every extra person that's going, we have to tack on $40. So do we have to keep plugging numbers in here? No, we can realize that little pattern. If 3 people go, an extra $40. 4 people go, an extra $40, and so on. Oops, 300 exact. Okay, so let's go ahead and look at this graph. We are dealing with people going, which is our independent variable, and we are dealing with cost of trip, which is our dependent variable. We have 6 people going, 1, 2, 3, 4, 5. I can't really do my skip a few, so I'm going to have each one of these represented as one person. Okay, we have to get all the way up to 300. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 is not going to work. 2, 4, 6, 8, 1, 2, 4, 6, 8, 2, 2, 4, 6, 8. That's not going to work. So unfortunately, it looks like, oh, I don't know. Let's go by 50s. Again, probably not the best because when we're trying to plot 0 people going on a trip with 60, we're going to have to just kind of guesstimate. 1 isn't too bad. 2. Okay, remembering that since we saw a pattern in our table, when we plot this, this is going to be a linear equation because we have our 2 variables with no powers involved. We also realize it doesn't ask us this, but just reviewing what we had last time, this is considered a discrete function because we can't have part of a person going on our trip. Okay, so there's my not very straight line, but there is our graph that compares the amount of people going on the trip. Okay, best way to do this type of problem is to put that information in a table. Next one, it says since they agreed to pay their manager for her work, they were getting low on money again and only had $300 in the fund. We're supposed to create a graph that compares the amount of people going on the trip again. So people going. This is a little bit different though, to the amount of money left in their account. So a little bit different here. Okay, let's go ahead and do this. The amount of people going, and if there is 0 people going, we're not going to put the gas into play. We did that on this last one because I'm going to bring that up a little bit later. That helped us with the linear functions. We're going to pretend if they decide to stay home on this one, they're going to have $300 left in their account. Okay, if they have 1 person going, that's going to cost $200 or $100. So we're down to $200. They have 2 people going. You know what? I think we almost, in order to make this linear, I know that this is a real world situation, but we're going to have to say that if nobody's going, we still have to pay for that gas. So they do actually have only $240 in their account because we're going to subtract this. So 300 minus that 60 there is 240. 300 minus that 100. 300 minus the 140. So again, notice that we have a pattern going. We're dropping by $40 each time until we run out of money. So looks like if 6 people go, they have no money in their account. We are going to graph this. So still dealing with people going down here. But now again, money in account. This is going to be a little bit different graph than we're used to because look at this. If 0 people go, we have $240 in our account. Let's see if we can make it now if we go by 40s. Yeah, maybe we could have went by 2s, but this is okay for now. People going, we have 1, 2, 3, 4, 5, and 6. So if 0 people go, we have $240 in our account. If 1 goes, we have 200, and we are going to, at a constant rate, decline until we have no money left. So a different type of equation because here we actually have 2 different intercepts, and that's what we're going to talk about in this next section, our intercepts. This is the y-intercept. It represents the amount of money if no people are going. This is our x-intercept. This represents, again, the amount of money if 6 people are going, that we have no money in our account if 6 people are going. So what we're going to have to do is interpret these 2 numbers. What do they mean? It's not just a dot on a graph. That means if no people are going, we have $240. But if 6 people are going, we have none. And understanding that this is the x-intercept, but because it's crossing the x-axis. This is the y-intercept because it's crossing the y-axis. Okay, so dealing with graphing equations by tables, another tip and trick that's going to show up in the notes, as well as identifying intercepts. Go ahead and get out your notes for this section. Okay, objectives of this section are to locate points on a coordinate plane, which we already know how to do, and graph 2 variable linear equations, which we have practiced on, but again, this will give you some nice quick tips to work with. All right, as in the introduction, we talked about that linear equation. It's an equation that forms a line when it's graphed. One way to write a linear equation is in standard form, where it has ax plus by equals c. Looks kind of fancy, but understanding that a and b are coefficients and c is just a constant number. So basically, it just means that our x and our y values are on the same side. They show you the words there. They give you some examples. Again, stipulations are that a and b cannot both be 0, and they have integers with the greatest common factor of 1, which means no fractions. That's what that means. So let's go ahead and look at these and see if they pass the test on whether they're a linear equation. If they are, we're supposed to write them in standard form. So step number 1, we have to look that we have 2 variables, check. We have them as only a power of 1, check. We should be good. They're both not 0, so we do have coefficients out in front of our x's and y's. So is this a linear equation? Yes, it is. It does say that if it is a linear equation, we have to write it in standard form. Standard form means the x's and y's have to be on the same side. We need to write it as the x term plus the y term equals the constant, which means this negative 3x is on the wrong side. So we're going to use our literal equation practice, and I'm going to add a 3x to each side. So without changing the value of this, I'm just going to rewrite it as 3x plus y equals 4. That is in standard form because here's my coefficients, my x's and y's. I have my constant that it's set equal to. Okay, looking at B, again, we have our 2 variables of x and y, but we have a problem here because we need a coefficient for that y. We have a variable. So this cannot be a linear equation because we have two variables together and there's no way that we can split them apart. So if we have two variables being multiplied together, we're not going to be able to create a linear equation. Okay, try to remember those type of problems. As a hint on this one, remember that we can't have any fractions. So see if you can think about how to rewrite 1A on guided practice. Okay, 1A is a trick question because x doesn't show up. But remember, one of the stipulations is that both of the coefficients cannot be 0. One of them can be 0. So the coefficient for x, why it doesn't show up, is because that coefficient is 0. So yes, this actually is a linear equation. We do have to write it in standard form. Standard form states that we can't have any fractions. So to get rid of a 1/3, I multiplied each side by 3 in order to get rid of it. So I just have y equals -3. This is actually in standard form because there's a ghost little 0x out there. To show you, to make sure that we understand this is a linear equation, later when we graph this, this is what that equation is going to look like. So it is a line. It's just a horizontal line. 1b, we should have said no, because stipulations, they both have to have the power of 1. We have a power of 2 here. This is not going to form a line. All right, moving on. We had talked about the intercepts on our introduction, so I'm just going to go ahead and read through this. A linear equation can be represented on a coordinate graph. The x-coordinate of the point at which the graph of an equation crosses the x-axis is the x-intercept. So right here we see the x-intercept. It's crossing that x-axis right there. Notice the y value is 0. The y-coordinate of the point at which the graph crosses the y-axis is called the y-intercept. Again, crossing the y-axis. Notice the x is 0. And this is where sometimes the kids want to say that this is the y-axis because the y is 0, but that's not true. The opposite is going to be 0. The graph of a linear equation has at most one x-intercept and one y-intercept, unless the equation is x equals 0 or y equals 0. In that case, it goes straight up and down the axis itself. Okay, so let's go ahead and look at this. Just kind of interpreting a graph to understand what we're looking at. We're supposed to find the x and the y-intercepts of the graph at the right. Well, again, y-intercept, where it crosses the y-axis, is right here. So y-intercept is at 30. Which one of these say that? These first two. So we know it could be one of these two right here. X-intercept, we go, here it is, it crosses at 20. So the x-intercept is 20, y-intercept is 30. Okay, let's go ahead and look at guided practice together because this one's a little bit tricky. We're supposed to find the x and the y-intercepts of the graph. So let's go ahead and start with y. I'm going to go down until it hits, bam, right at 150. So y-intercept is 150. It could be one of these two right here. Now I'm going to go across to figure out where it crosses the x-axis. It's never going to cross the x-axis because it's going straight across. So that doesn't mean that the x-intercept is 0. That would actually mean that it crosses right here. It means that there's no x-intercept, which happened on one of our, that one graph that I showed you right here, that sometimes the linear equation is only going to have one intercept. If it's a horizontal or a vertical line, that is going to happen. Still considered a linear equation because look at this. It is still a line. It's just a special type of line. Okay, moving right along. Looking at our swimming pool, this is where we have to interpret those intercepts and explain what they mean. A swimming pool is being drained at a rate of 720 gallons per hour. The table shows the function relating the volume of water in a pool and the time in hours that the pool has been draining. So we're supposed to find the x and the y-intercepts of the graph of the function. So x-intercept and y-intercept. Okay, looking at this table, okay, our x-intercept is going to be down here at 14. Okay, x when y is 0. So x-intercept, maybe we're going to put that when y is 0. The y-intercept is when x is 0. So when the opposite value is 0. So 14 is our x-intercept. Our y-intercept is 10,080. Again, let's interpret what that means. So at the time of 14 hours, we have no water in our pool. When we started draining, we had 10,080 gallons. So at the time of 0, before we started draining, we had 10,080 gallons of water in our pool. And of course, that's what we were supposed to do on this one. So let's go ahead and write that down. The sentence, when they, sometimes I use we, I don't know why. When they started draining pool, and then I can't spell sometimes either. Comma, there was 10,080 gallons of water. That explains the x-intercept. After 14 hours, the pool was empty. Okay, notice I didn't state very many math terms in there. I didn't even put in x-intercepts and y-intercepts. I'm just supposed to describe what they mean. So real world concepts that we have to look at these numbers and we have to write them in simple terms so we understand what they mean. All right, go ahead and try that with guided practice 3. Again, we're going to state what they are and then describe what they mean. Okay, one common mistake with students is that they want to look at x-intercept and say that it's the 248. Remember, x-intercept is when y is 0. So focus on that 0 of y, move over, x-intercept is 4. Y-intercept, focus on the 0 of the x, move over, and our intercept is 248. So what does this mean? We're dealing with time and distance. This is saying that they were 248 miles from the park. It took them 4 hours to get there. Very short and simple, but we can look at a table and we can interpret that and write it in, again, everyday terms. Okay, now we're going to graph. We have been used to putting tables together. Now we're going to look at something else. Graphing these linear equations, it says by first finding the x and y intercepts, you have the ordered pairs of 2 points through which the graph of the linear equation passes. This information can be used to graph the line because only 2 points are needed to graph a line. So again, instead of creating a table, we're going to go ahead and plug in 2 values and figure out which values go with them. So when we look at those x and y intercepts, if I want to figure out that x-intercept, I'm going to plug a 0 in for y. So I'm going to write 2x plus 4 times 0 equals 16. What that's going to give me is the x-intercept. So what I'm going to do is basically I'm going to figure out the point of when y is 0, what is x? Well, I'm going to keep going. 2x equals 16. If I solve this equation, x equals 8. Okay, so when y is 0, x equals 8. There's 1 point. I'm going to go ahead and plot that. That is at 8, 0. X-intercept crosses the x-axis right there. Now I'm going to go opposite. I want to find the y-intercept, which means I'm going to plug a 0 in for x this time, and I'm going to solve from there. So looking at this, I have 2 times 0 plus 4y equals 16. I have 0 here, so I have 4y equals 16. Divide by 4, y equals 4. Okay, when they're written in standard form, a very good way to find 2 points, because look at that. Instead of creating a crazy table, I have 2 points that I can connect the dots because I know that this is a linear equation. And there it is. All right, looking at this next one, it says that we're supposed to, again, graph by using the x and y intercepts. Notice that up on that top one, I said if it's in standard form, it's really nice to use. This one isn't because my x's and y's aren't on the same side. So I'm going to quickly just take one little step and I'm going to subtract that y over. So I'm going to have an x minus 3y equals 3. And the reason I'm going to do that is now I can quickly solve this. So one way that I tell my students how to do this, instead of going through all of these steps right here, I know that if I plug a 0 in for a value, everything around it is going to disappear. So if I call it the cover and solve. So if I'm trying to find the x value, what I'm going to do is I'm going to cover the y value and I'm going to solve for it. So look at that, covering and solving, x equals 3, because I know anything around that y is going to totally disappear. So I know that my x-intercept is at 3. Bam. Now I'm going to cover and solve to find my y. I'm going to get rid of my y and I'm going to do some quick computations in my head. Okay, I have a negative 3y equals a 3, which means I'm going to have to divide by a negative 3 on each side. So my y-intercept is negative 1. So going back to 0, please realize that that is not the point 3, negative 1. That means that I have x equals 3, y equals 1. There's my 2 intercepts. I can go from there. So again, I call that just the quick cover and solve and doing a couple little steps in your brain. Going back up to this one, let's go ahead and see if that works, just to make sure we understand what I did. Again, I was trying to find my x-intercept. Whoops, that's not big enough. So I covered up my y, and I ended up with 2x equals 16. So 16 divided by 2 was 8. That's where my 8 came into play. Then I had to find my y-intercept, so I didn't care about my x. I have 4y equals 16. 16 divided by 4 is 4. That's where I got those 2 points. If you're not comfortable with that, definitely go through these steps if you want to. Otherwise, that's what we just call the kind of cover and solve in order to get those quick 2 points. Okay, go ahead and try that for guided practice 4. Okay, 4A is in standard form, so I'm going to go ahead and just look at that cover and solve. Understanding that if I'm looking for my x-intercept, I'm going to go ahead and not even care about that y. I'm going to plug a 0 in there. I have a negative x equals 3, so I have to change that negative to the other side. I ended up with x equals negative 3, which is right there. Okay, looking at the y-intercept, I don't care about the x anymore. I'm going to get rid of him, and I'm going to go ahead and quickly solve for that y. Well, y equals 3 over 2, or 1.5, which is right there. Okay, cover and solve, a quick little way in order to get those 2 points. Looking at 4B, I had to do one little step because I like looking at this in standard form, so I added that x over. And again, I did a little bit of cover and solve. Trying to find my x, I just have, look at that, x equals negative 5. Didn't have to do any math. Now I'm going to look for my y-intercept, covering up my x, same thing, y equals negative 5. Understanding, again, that that is not a point. As soon as I find that x equals negative 5, I go and find that value on the intercept, or on the axis, and I put a dot. As soon as I see y equals negative 5, I find that on the y-axis, and I make a dot. Okay, so standard form is awesome. We did just go over this part right here that says, again, remember, sometimes we do have special situations where we have horizontal lines or vertical lines, and we are going to look at those a lot. So by the end of this whole class, you should be pretty comfortable with recognizing the difference between them. Okay, very last example says that we're supposed to graph by making a table. Again, in math, always 20 different ways to do something, and there is many different ways to graph. So some of these we are going to make a table, Others, we're going to use our resources and look differently. All right, so looking at this one, not in standard form, and I see that I'm dealing with a fraction. So probably easier maybe to make a table on this one. So I'm going to plug in a couple x values and figure out which y value goes with it. Usually I like my 0, 1, and 2, but I notice that I'm dealing with a fraction. So I am going to stick with 0, but instead of 1 and 2, which doesn't multiply very nice by 1/3, I'm actually going to use 3. I'm going to think ahead because I know that 3 is divisible, or 3 and 1/3 will help me out. So I'm going to plug a 0 in over there. I have y equals 1/3 times 0 plus 2. So I know that when x is 0, y equals 2. Okay, I'm going to look at this one in green because I'm going to plug 3 in there instead. So when x is 3, y, and the reason why I have 3, look, that simplifies down nicely. Y is actually 3. So I'm going to go ahead and plot those 2 points at 0, 2, and at 3, 3. Where's 3, 3? Right there. Okay. Earlier they said linear equations, all we have to do is have 2 points, so we can just connect the dots and know that we're going to have a nice straight line between them, except for me because my lines are never straight. All right, here's one of those special type of situations where we're just supposed to graph y equals -2, understanding that we know we're going to have either a vertical or a horizontal line. We're just going to have to figure out which kind. Okay, well this means that y is always -2. So I'm going to put 2 values of -2 over here. And that again means that no matter what x is, y is always -2. So I'm going to plug my 0 in there and my 1. And I'm going to go ahead and plot those points. 0, -2, 1, -2. So this is a horizontal line through y equals -2. Okay, go ahead and try, well, you know what? We're going to do guided practice together because I noticed something right here. They say to make a table, but look at this. This is nicely in standard form. We realize that standard form doesn't have to have tables. So I'm going to go back to my cover and solve. I'm going to figure out what my y-intercept is by this. So I realize that I have 2x equals 2. So I know that my x-intercept is at x equals 1. So I'm going to go right away down and I'm going to plot that point. Okay, I'm going to do the same thing with y. I don't care about that x because I'm technically putting a 0 in there. Those negatives sometimes are kind of tricky. That negative is part of y. We're trying to get y completely by itself. So in order to get rid of that negative, we're going to just switch signs from each side. That y becomes positive, that 2 becomes negative. So I know that my y-intercept is at -2. A little bit quicker than putting together a table. Okay, and very last one. Again, kind of a special situation because we just have one variable, but I'm going to set up my table and figure out what that means. Again, it is saying that x is always going to be 3. So I'm going to put 2 3s in my x column, and then I'm just going to throw some y values in there because it doesn't matter what they are, that x is always going to be 3. And I'm going to go ahead and plot those 2 points. I have 3, 0, and I have 3, 1. So look at this, connecting those dots, we have a vertical line. Okay, so talking about graphing, really focused on intercepts, first off what they mean, how to interpret them, and then also how to use them when we're graphing standard equations that we can cover and solve and get those 2 quick points so we can go ahead and graph. All right, you are officially ready for the assignment for this section.